Hello and welcome to my channel. In this video we will solve problem 4 of miscellaneous exercise on chapter 4 of 12th class. So the fourth problem is, let A be equal to 821231115. Verify that first adjoint of A the whole inverse is equal to adjoint of A inverse, and second A inverse the inverse is equal to A. Okay. So let us start solving this problem. Solution: to verify, in the first problem, to verify bracket adjoint of A the whole inverse is equal to adjoint of A inverse. Okay, so given is what? A equal to 1 to 1, 2 3 1 and 1 1 5. Okay, we have to find first adjoint of A. So for finding adjoint of A we have to find cofactors of A. So cofactors of A, that is A11, which is equal to minus 1 raised to 1 plus 1, and 5 times 3 is 15 minus 1. So minus 1 raised to 2 times 14, which is nothing but 14. Okay, then A12 is equal to minus 1 raised to 1 plus 2 bracket 5 times 2 is 10 minus 1 times 1 is 1. So minus 1 raised to 3 times 9, which is nothing but minus 9. Okay, then A13 minus 1 raised to 1 plus 3 times 1 times 2 is 2 minus 1 times 3 is 3. So minus 1 raised to 4 times minus 1, which is minus 1. Then A21 is minus 1 raised to 2 plus 1. So 5 times 2 is 10 minus 1 times 1 is 1. So this will be equal to minus 1 raised to 3 times 9, which is nothing but minus 9. Then A22 is minus 1 raised to 2 plus 2, and so 5 times 1 is 5 minus 1 times 1 is 1. So minus 1 raised to 4 times 4, which is 4. Then A23, so minus 1 raised to 2 plus 3. Then 3 times 1 is 3 minus, so 3 times 1 is 3 minus 4, which is equal to minus 1 raised to 5 minus 1, which is nothing but 1. Okay, then A31, which is equal to minus 1 raised to 3 plus 1. So 2 times 1 is 2 minus 3 times 1 is 3. And minus 1, so that is minus 1. Then A32, so minus 1 raised to 3 plus 2. So 1 times 1 is 1 minus 2 times 1, which is 2. So that is nothing but minus 1 raised to 5 times minus 1, which is 1. Then A33, so minus 1 raised to 3 plus 3, so 3 times 1 is 3, minus 2 times 2 is 4, so that is minus 1 raised to 6 times minus 1, which is minus 1. Okay, so adjoint of A we can now write. So adjoint of A is equal to matrix 14 minus 9 minus 1, then minus 9 4 1, and minus 1 1 minus 1. So this is adjoint of A. Now we have to find the adjoint of A inverse. Okay, so what we have to find is now the cofactors of adjoint of A. So cofactors of adjoint of A, so we can write it as B. Okay, suffix. So B11, so minus 1 raised to 1 plus 1 times minus 4 minus 1, then minus 1 raised to 2 times minus 5, which is nothing but minus 5. Then B12, so minus 1 raised to 1 plus 2, minus 1 raised to minus 9 is 9, and plus 1, minus 1 raised to 3 into 10, which is nothing but minus 10. Then B13, which is equal to minus 1 raised to 1 plus 3, first row and third column. So minus 9 plus 4, which is equal to minus 1 raised to 4 times minus 5, which is equal to minus 5. Then B21 is equal to minus 1 raised to 2 plus 1. So second row and first column, that is nothing but 9 plus 1. So minus 1 raised to 3 times 10, that is minus 10. Then B22 minus 1 raised to 2 plus 2 times minus 14 and minus 1, which is equal to minus 1 raised to 4 times minus 15, which is equal to minus 15. Then B23, which is equal to minus 1 raised to 2 plus 3, right? So second row and third column we have to delete. So 14 minus 9. Okay, so what we will get is minus 1 raised to 5 times 5, so which is equal to minus 5. Okay, then B31 we have to find. So B31 is equal to minus 1 raised to 3 plus 1 minus 9 plus 4 minus 1 raised to 4 times minus 5. So minus 5. So B32, so third row second column we have to delete. 14 minus 9, so minus 1 raised to 5 times 5, which is equal to minus 5. Then B33, which is minus 1 raised to 3 plus 3 times 14 times 4 is 56, and Minus 9 times minus 9 is minus 81, which is equal to minus 5 raised to 6, and 81 minus 56 will be 81 minus 56, 11 minus 6 is 5 to 25, which is equal to 25. Okay, so adjoint of A, we can write adjoint of A, uh, yeah, will be equal to B11, that is minus 5, B12 and B13 minus 10 minus 5, then minus 10 minus 15 minus 5, and then minus 5 25. Okay, now we have to find the determinant of adjoint of A, right? We have to find adjoint of A inverse, so for that we have to find determinant of adjoint of A. So determinant adjoint of A is this here, so 14 minus 9 minus 1, then minus 9 4 1, and minus 1 1 minus 1. So we will get 14 times minus 1 times 4 is minus 4, minus of 1 times 1 is minus 1, and plus 9 times minus 1 times minus 9 is 9, minus 1 times 1 is plus 1, because minus of minus 1 into 1 it is, so plus 1, then 1 times minus 9 is minus 9, minus of minus 1 times 4 is plus 4, so we will get 14 times minus 5 plus 9 times 10 minus 1 times minus 5. Okay. So this will be minus 70, 14 times minus 5, and plus 90 plus 5. Okay, so 90 minus 70 is 20, plus 5 is 25. Okay, so this is not equal to 0, so therefore adjoint of A the whole inverse exists. Okay, so adjoint A inverse will be nothing but 1 by determinant of adjoint of A times adjoint of A multiplied by adjoint of A, not multiply, adjoint of A. This will be equal to 1 by determinant of adjoint of A is 25. Okay, then adjoint of A is this, so minus 5 minus 10 minus 5 minus 10 minus 15 minus 5, then minus 5 minus 5 25. Okay, here there is a mistake, right? This is minus 25, so this is minus 25 here. Okay, so this is minus 25 here. Now we can take this inside this matrix. What we will get is minus 1 by 5, right? Minus 5 divided by 25 minus 1 by 5. Similarly this will be 2 by 5, this is 1 by 5 here, then minus 2 by 5, then minus 3 by 5, minus 1 by 5, minus 1 by 5, minus 1 by 5 and minus 1. Okay, so this is the adjoint of A, the whole inverse, right? Adjoint of A, the whole inverse. Now what we have to find is the right hand side, that is this adjoint of A, the whole adjoint of A inverse. So for that we have to find A inverse, right? For finding A inverse we have to find determinant of A. So determinant of A will be determinant of 1 2 1 2 3 1 1 2 1 2 3 1, then 1 1 5. So that will be nothing but 1 times 15 minus 1 minus 2 times 10 minus 1 plus 1 times 2 minus 3. Okay, so this is 14 minus 2 times 9 will be 18 plus 2 minus 3 will be minus 1. So minus 18 minus 1 will be minus 19. Minus 19 plus 14 will be minus 5. Okay, is not equal to 0. Therefore, A inverse exists and A inverse will be equal to 1 by determinant of A, adjoint of A, right? So 1 by determinant of A is minus 5. Adjoint of A is here, this 14 minus 9 minus 1. Then minus 9 4 1, and then minus 1 1 minus 1. So A inverse will be equal to, we can take this inside here, so minus 14 by 5, then 9 by 5, 1 by 5, 9 by 5, minus 4 by 5, then minus 1 by 5, 1 by 5, minus 1 by 5, 1 by 5. Okay, this is the A inverse. Now we have to find adjoint of A inverse. Okay, so adjoint of A inverse we have to find. For that we have to find cofactors of A inverse. Okay, so C11 is equal to minus 1 raised to 1 plus 1 times minus 4 by 5 times 1 by 5 is minus 4 by 25, minus of minus 1 by 5 minus 1 by 5 is 1 by 25. So minus 1 raised to 2 times minus 5 by 25. So that is minus 1 by 5. C12 minus 1 raised to 1 plus 2, then 9 by 25 minus plus 1 by 25. So minus 1 raised to 3 times 10 by 25, which is nothing but minus 2 by 5. Then C13 minus 1 raised to 1 plus 3 times minus 9 by 25 plus 4 by 25, which is nothing but minus 1 raised to 4 times minus 5 by 25, which is 1 minus 1 by 5. Then C21, which is minus 1 raised to 2 plus 1. So second row, first column we have to delete. 9 by 25. 9 by 25 minus plus 1 by 25. So that is nothing but minus 1 raised to 3 times 10 by 25, which is nothing but minus 2 by 5. Okay. Then C22 minus 1 raised to 2 plus 2, uh, second row, second column we have to add minus 14 by 25 minus 1 by 25. 1 by 25. So that is minus 1 raised to 4 times minus 15 by 25. That is minus 3 by 5. Okay. Then C23 minus 1 raised to 2 plus 3. So we will get 14 by 25 minus 9 by 25, which is equal to minus 1 raised to 5 times 5 by 25, which is minus 1 by 5. Okay, then C31 minus 1 raised to 3 plus 1. So third row and first column here to minus 9 by 25 plus 4 by 25. So that is minus 1 raised to 4 times minus 5 by 25, which is minus 1 by 5. Then C32 is minus 1 raised to 5, right? So the third column and third row and second column we have to add. So minus 4 plus 14 by 25 minus 9 by 25. So which is equal to minus 1 raised to 5 times minus 5 by 25. Sorry, plus 5 by 25, which is minus 5 by 25, which is minus 1 by 5. C33 minus 1 raised to 6 times 56 by 25 minus 81 by 25. 56 by 25 minus 81 by 25. So that is nothing but minus 25 by 25, which is minus 1. Okay. So now what we can do is write adjoint of A inverse. So that is equal to minus 1 by 5 minus 2 by 5 minus 1 by 5, then minus 3 by 5 minus 1 by 5 minus 1 by 5 minus 1 by 5 minus 1. Okay. So this is adjoint of A inverse. So we can call this as 2, and wherever we have found the LHS for here, so this we can call it as 1. Okay, if you look at 1 and 2, they are same. Okay, so 1, this is 1. If we check the first row is minus 1 minus 2 minus 1, then minus 2 by 5 minus 3 by 5 minus 1 by 5, which is the same here, and minus 1 by 5 minus 1 by 5 minus 1, which is the third row, which is same. So from 1 and 2 from 1 and 2, we get adjoint of A, the whole inverse, is equal to adjoint of A inverse. Okay, so this was the first part of the question. Now let us go to the second part. So to verify that A inverse, the whole inverse, is equal to, this is the second part, right? So now what we have to do is we have to find the LHS here. So that is A inverse of inverse. So that means we want to write the adjoint of A inverse here. Okay, adjoint of A inverse, which we have found out, right? So where is adjoint of A inverse? Yeah, here. So minus 1 by 5, minus 2 by 5 by 5, minus 1 by 5, and we have minus 2 by 5, minus 3 by 5, minus 1 by 5. And third row is minus 1 by 5, minus 1 by 5, minus 1. Okay, so adjoint of A inverse we have. So to find A inverse of inverse, you have to look at the formula. So A inverse of inverse will be nothing but 1 by determinant of A inverse, right? Adjoint of A inverse. So what we have to do is find the uh, determinant of adjoint of A inverse. So determinant of adjoint of A inverse. First, what we will do, find the determinant of A. We have found out determinant of A, I think. Yeah, here minus 5. Okay, so determinant of A inverse will be nothing but determinant of A uh, inverse, right? That is reciprocal. So that means we will get 1 by determinant of A. So that is 1 by determinant of A was minus 5. So this is the uh, determinant of A inverse. So that means therefore A inverse is equal to 1 by determinant of A inverse. So adjoint of A inverse. So 1 by determinant of A inverse is minus 1 by 5. So here minus 1 by 5 times adjoint of A inverse is here minus 1 by 5 minus 2 by 5 minus 1 by 5, then minus 1 by minus 2 by 5 minus 3 by 5 minus 1 by 5 minus 1 by 5 minus 1 by 5 minus 1. So this will be equal to, see, if you multiply 1 by minus 1 by 5 here, what you will get? Multiplied by 1 by minus 1 by 5. So this will get cancelled. So what you will get is 1. Here you will get 2, then 1, then 2, 3, 1, 1, 1, and 5. Okay. So if you look at this, this is nothing but A. 1 2 1 2 3 1 1 2 1 2 3 1 1 1 5, right? 1 1 5. So this is A, right? So A inverse is equal, A inverse of inverse is equal to A. So hence proved. So that's it in the video. If you like the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I'll see you in the next video.